We defined how to add, subtract, and multiply polynomials, so for this lesson we're going to focus on polynomial division. So basically we're going to go over an algorithm that will do this for us, and that algorithm is the same as what you would use on integers. So I'd like to look at these two examples. That is 5 divided into 205, as well as 6 divided into 205. So for this first example, the way we'd go about it is we would take 5, put a division symbol, and write 205. And we go through by saying, well, okay, does 5 go into 2? It does not. You could put a 0 up here, but typically we don't. And you'd move over to the next place value. So does 5 go into 20? And the answer is yes, it goes in a total of 4 times. So this is what you have to come up with. You have to think of, oh, well, 4, when I multiply it to 5, gets me 20. In fact, it matches up perfectly. And then the number that you put there, you have to subtract it. And when you take the difference, you get 0. And the next thing is to bring down this 5. Okay, we're at our last place value. We have to think of something that when I multiply it to this number, it gives me 5. That is an obvious choice of 1. 1 times 5 gives me 5. And then I subtract that amount. And what do you know? I have a remainder of 0, and that is not a surprise. I knew 5 was going to divide evenly into 205. Now, what does all this work tell us? It tells us that if you multiply 5 and 41, it takes you back to 205. So I'm going to put that over here. 5 times 41 is 205. So division breaks things apart, and multiplication puts it back together. Now, if we compare this to 6 divided into 205, obviously this one's not going to work out perfectly, but just to check it out. Okay, again, 6 does not go into 2, so I don't put anything here. I move over, and okay, 6 goes into 20 3 times. That's as close as we can get. It gives us 18, and I subtract that amount, and I'm left with 2. I then bring down the 5 and repeat this process. 6, how close can we get to 25? 24 if we multiply by 4. So I'll put 24 here. I subtract that amount. And this time I'm actually left over with a remainder of 1. Now what does that mean in this context? What this means is if you take 6 and you multiply it to 34, it almost gets you to 205. You just have to add 1 more to get there. So this is equal to 205. Over here it worked out perfectly. There was no remainder to add. It took you directly to 205. This time, if we divide by 6, it got us really close, but you have to add 1 more to get to our final answer. So let's use this idea, this algorithm, to divide polynomials. The only difference is going to be we need to use some rules of exponents, but the logic is the same. So what I'm going to do is take 5x and divide that into this polynomial. So I'll write 5x, I'll set up my division problem, and then copy down 20x cubed minus 10x squared minus 5x, and I'm going to put a plus 0 at the end. Notice up here, 0 appeared as one of our digits, but we didn't leave it out. We had to put it in here. Down here I have x cubed, x squared, x to the first, and you could possibly have a number at the end, so I just put a 0 in its place. If something's missing, I'd like to refer to it within the problem. Anyway, the goal is to now cancel 20x cubed, and we're going to multiply something to 5x to get to 20x cubed. So just like up here we had to make a choice, it's our choice to figure out what that is. I know 4 times 5 gives me 20, and an x squared times an x to the first would give me x cubed. So that's going to be the first piece, 4x squared. The reason is 4 times 5 gives me 20, and x squared times x gives me x cubed. I copy that down, and I have to subtract that. And it gives me 0, which I don't have to write, and I just bring down the next piece. Okay, now I repeat this process where, all right, how many times does 5x go into a negative 10x squared? And it has to match up perfectly. Well, 5 times negative 2 gives me negative 10, and an x times an x gives me an x squared, so that's my next piece. it's minus 2x. And the reason is negative 2 times 5 gives me negative 10, and x times x gives me x squared. So I get negative 10x squared. And I'm subtracting this thing. And a minus becomes a positive. Those two things cancel, give me 0. I won't write that either, and in fact, I'll just bring down this minus 5x. Okay, let's see. I now have to multiply by negative 1, because negative 1 times 5x gives me negative 5x. And when I subtract that, I have a remainder of 0. And there it is. I know I'm done because I'm at my last place value. And notice that this also worked out nicely where the x squareds are above the x squareds, the x's are above the x's, this number is above the spot for the number, and that's the answer to this problem. What this is telling us is, if we multiply 5x to 4x squared minus 2x minus 1, it would take me back to this original polynomial. Just like up here, this times this gave me this. This times this would give me this. So let's try this with a slightly more complicated example, where I want to divide 2x plus 1 into 6x squared plus 13x plus 5. Notice that nothing is missing. It goes squared, first, numbers, so I don't have to fill anything in. But the difference here is the thing I'm dividing by now has two pieces. How is that going to change this process? What we're going to do is try to cancel the 6x squared by multiplying something to 2x. But then we're going to see how this 1 plays a role. Okay, if you want to get a 6, you have to multiply this thing by 3. And if you want to get an x squared, you have to multiply this thing by x. So my first piece is going to be 3x. Again, I'm putting that above the x's. So you have to take this and multiply it down here. That means it's going to be multiplied to both of these terms by the distributive property. So first, 3x gets multiplied to 2x, and we get 6x squared. That's perfect. But then 3x gets multiplied to 1, and we get 3x. So that's different. We now have two pieces that come out because you have to distribute this 3x to both of these terms, and I'll list them here. Okay, the next thing to look out for is you are subtracting this. But when you subtract this, you want to make sure you're subtracting both pieces. This negative gets distributed to both terms. 6x squared minus 6x squared is 0. You don't have to write it. But here we have 13x minus 3x. This is really 13 minus 3, which is 10x. And I now bring down 5. We only have one thing left to do. I have to try to cancel this 10x by multiplying to 2x plus 1. That's going to be very easy. In fact, if I multiply this by 5, 5 times 2 gives me 10, and then I just have an x that carries along, so I'll put plus 5. 5 gets multiplied to 2x, like I said, which gives us 10x, and 5 gets multiplied to 1, which gives us 5. I'm now subtracting this thing, and what do you know? We get a remainder of 0. 10x minus 10x is 0. 5 minus 5 is 0. I think I'll actually put this 0 down here so we can actually refer to the remainder. But that's it. What all this work tells us is if you take 2x plus 1 and you multiply it to 3x plus 5, it takes you back to 6x squared plus 13x plus 5. So multiplication would take you back here, whereas division splits it apart. And I wanted to try one more, perhaps where the remainder is not going to be 0. So let's check that out. X minus 1 divided into, okay, I have 3x cubed. I'm noticing there's no x squared, so I'm going to be careful here and put 0x squared, so I have a spot to refer to. Then I'll put plus 2x minus 1, and I think we're good to go. What I'd like to do is cancel 3x cubed by looking at this x. I know I have to multiply by 3 as well as x squared, so that's my first choice, 3x squared. This is why putting in the 0x squared is nice, because it gives you a spot to write this answer up here. Anyway, 3x squared times x gives me 3x cubed. But then 3x squared times negative 1 is minus 3x squared. I am subtracting this, so you gotta be careful here, but 3x cubed minus 3x cubed is 0. 0 minus a minus, that's really plus. That's 0 plus 3, so we get 3x squared. And then I'll bring down the 2x and repeat this process. Okay, and I want to cancel a 3x squared, so I have to multiply this by 3, but also by x. Okay, so 3 times this 1 gives me a 3, and x times x gives me x squared, so I do in fact get my 3x squared. And then 3x times negative 1 is minus 3x, and I now subtract that. 3x squared minus 3x squared is 0. 2 minus a minus, that's plus, that's 5x. And I bring down the minus 1. Okay, I'm at my last step. Okay, I want to cancel a 5x, so I'm going to multiply this by 5. I get 5x minus 5, and when I take the difference, we get 5x minus 5x, which is 0. Negative 1 plus 5 is 4, so here we have a remainder of 4. What does this all mean? It means if we take x minus 1 and we multiply it to 3x squared plus 3x plus 5, it's almost equal to 3x cubed plus 2x minus 1. But we have to add on the remainder of 4 to get there. So it's the product of these two things plus your remainder that would take you back to the very first polynomial that we started with.